Hello everyone, welcome to my channel. Today we'll be solving May 20. Even though it says May 20, the exam was not held in May 20. The exam was held in October 20 because of COVID. This is Unit 3 paper. It's a very important paper, so let's get started. This is a walkthrough. I have already solved this. I'll be just guiding you through the entire paper, and you can of course download the PDF from Excel Physics. The link is posted in the description below. Question says, a student is investigating the effect of temperature on the viscosity of oil by measuring how fast the oil flows through the funnel. He uses the apparatus shown. State a piece of apparatus the student could use to vary the temperature of the oil. Okay, so the question does not say state an apparatus that the student should use to measure the temperature. The keyword over here is vary. What do I use to vary the temperature? It's always a water bath. And the common word in the question is state. The keyword is vary, the command word is state. Therefore, you don't have to explain your choice. You just need to vary the temperature and measure it. Water bath easily enables you to do both. Now, state the piece of apparatus the student could use to measure the time taken for the oil to flow to the funnel. It's very obvious. It's a stopwatch, of course. The two thermometers shown below are available. One is an analog one, the other one is the digital version. He chooses to use the digital thermometer. Justify his choice. Okay, so you have to understand and remember something at all times, and that is, in any form of measurements and experiments, we always try to reduce the percentage uncertainty. So whenever you are asked to justify the choice of measuring instrument, always a follow-up point is to reduce the percentage uncertainty. So a digital thermometer has a higher resolution. There would be no parallax error in digital thermometers. Therefore, the percentage uncertainty would be smaller. So like I said, the second point has to be pointed towards percentage uncertainty. So a lot of students might feel that the first point should account for 2 marks. Always remember, the ultimate objective for choosing any measuring device is to lower the percentage uncertainty. So, of course, mentioning the second point is mandatory. Identify one control variable in this investigation. There is the mass or volume of oil. The entire experiment is based on the idea of how fast the oil flows. The idea is if the oil is more viscous, the time taken would be longer and vice versa. However, if you start off with a larger volume or mass, the time would also be longer. Therefore, it would not be possible to identify which factor is determining the time for fluid to flow. So we are trying to determine the viscosity and how the viscosity affects the rate of flow or the time it takes for the oil to flow. No other factor should come into play. And describe how this variable can be controlled. Check the volume of the fluid remaining in the measuring cylinder after pouring each time. So you need to check how much volume we are pouring in. Let me remind you one more time, you can download the entire PDF from Excel Physics and the link is posted in the description. The student initially measures the time from the starting point to pour the liquid into the funnel to the last drop of oil falling from the funnel. State how the rate of flow of oil should be calculated. Guys, rate of flow. I think you remember this from your IGCSEs. Rate of flow is always volume divided by time. So that's how you find out the rate of flow. The volume of oil divided by the time taken for the oil to flow through the funnel. And it's always a good practice to write the entire sentence. The next question says, describe how the same apparatus could be used to calculate a more accurate value for the rate of flow of oil. A more accurate, the keyword over here is more accurate. So it's much easier to start and stop the stopwatch when you have a visual reference. Let's say when you start the stopwatch when the volume has reached 10 cm cube and stop it when it has reached 60 cm cube. So you mark the points. And repeating the measurements reduces random errors and helps to identify anomalous readings, thus improves the accuracy. The circuit has to be set up in such a way that the timer starts when the fluid starts passing through the light gate and stops when the fluid has stopped flowing, that is, the light is not interrupted anymore. So these are the things I just wrote to explain the whole idea, and these are the points that you should be writing for your answer. Starting timer after the oil has been poured by a certain volume. So always mark some volumes, have some arbitrary values in mind. So you start when it has reached that certain level and stop when it has reached the other value that you have in your mind. And of course what you have marked. Stopping the timer before the fuel is empty. This part is very important. And both points towards the reason that I just explained. Repeat for the same temperature and calculate the mean time. Whenever an experiment talks about accuracy, it's always a good practice to repeat an average, and the other word for average is taking the mean. Use light gates and electronic timer to avoid human reaction time. Guys, it's so obvious. When you have to manually start and stop the stopwatch, there will always be some, the experiment will always be prone to human errors, and you can eliminate this, not just minimize, literally eliminate this by using a light gate and a timer. Now let's move on to our next question. A student investigated how intensity of light emitted by a light emitting diode LED varied with potential difference PD applied across the LED. She measured the intensity of light using the light meter, which was shielded from external light sources. She plotted her results on the graph as shown. So the graph was not given in the question. I had to draw it for you, and if you look at the graph very carefully, you'll see that the best fit line can be a curve as long as it's a best fit. So what exactly does a best fit mean? You need to ensure that there are equal number of points above and below the line of best fit. So in this case, above and below means left and right. So all of the points somewhat pass through the line, or in other words, the line passes through almost all of the points except for two. One is on the left and one is on the right. That's how you ensure a best fit line. So B1 says give a value of the PD at which LED starts to conduct. So if you look over here at even 1.5, it has not started conducting because the intensity is still 0. So the value has to be after 1.5. So a value could be 1.6. Then the question asks, calculate the minimum energy that must be transferred to an electron in the LED for light to be emitted. Question says minimum energy. Energy is always E equals to QV, and you just multiply the voltage that you just found out from the previous question with the charge of an electron. The only form of energy you can transfer to an electron is electrical energy, when it's in the circuit of course, which is equivalent to QV. And this is your answer, 2.6 times 10 to the power 19 minus 19. If you're finding this paper useful, the PDF will be even more useful. And again, let me remind you one more time, you can download this from Edexcel Physics. The link is posted in the description below. Light is emitted when the electron releases energy as a photon. This is basic quantum physics. The student tested a second LED which emitted light of wavelength 625 nanometer. From her results, she determined the minimum electron energy to be 3.1 times 10 to the power minus 19 joule. Calculate the value of the Planck's constant from this data. You just need to recall the photoelectric equation, or the energy of the photon. E equals hc by lambda. There are two, E equals to hf or hc by lambda. Why did we choose hc by lambda and not hf, energy of the photon? Because in the question the wavelength is given. Had the question talked about frequency, would have definitely gone with E equals to hf. And just substituting the values will give you the answer of Planck's constant. You just need to make h the subject of the equation. Question D says LED does not produce monochromatic light. Guys, you need to focus on the term monochromatic. Mono means single, chrome means color. So monochromatic means a single colored light. For example, the light that a laser produces, that's monochromatic. But a flashlight of your phone produces a white light that is not monochromatic. So monochromatic means single color. Since LED does not produce monochromatic light, it means that there are multiple colors involved. Each color corresponds to a different wavelength. So there would be a range of wavelengths. If wavelength was longer, calculated value of the Planck's constant would be larger. There would be a range of possible values of Planck's constant because there are a range of wavelengths involved. Let's look at part E. The accuracy of the value of Planck's constant calculated depends on the minimum PD determined from the graph. Explain how the student could reduce the uncertainty in her value of the minimum PD. Guys, please recall what was the minimum PD involved here. The value was around 1.6 and there weren't any plotting points there. You had to do some guesswork. So if you had taken some more values, you could have easily seen where exactly it starts conducting. So the answer is take measurements for additional PDs between 1.5 and 2.0 so you can see where the PD, where the line touches the x-axis. Number 3. A student investigated how the power output of a solar cell is affected by temperature. It's always a good practice to underline the quantities involved in any sort of questions. The intensity of light incident on the solar cell remained constant. So there were two variables involved here. One is the power output, the other one was the temperature. Now, the student determined the power output of the solar cell at different temperatures. Complete the diagram to show a circuit that would allow him to determine the power output of the solar cell. So I have already drawn the diagram for you, and please see the blue font. By the way, in your actual exam, you are not supposed to write what I've written in the blue font. Only the font in red is the answer. Now, read the question carefully. It says to draw a circuit. Therefore, you don't need to draw a water bath to change the temperature because that's not part of an electrical circuit. The question says draw a circuit, so I don't have to draw a water bath here. I just need equipment to find the current and the voltage. Let's move on to B. Describe how the student could ensure that the intensity of light incident on the solar cell remain constant. Guys, you need to recall what is the factor that affects intensity. If you can keep that factor constant, you are also keeping the intensity constant. Can you guess? 1, 2, 3, go. Same distance between the lamp and the solar cell. The larger the distance, the smaller the intensity. I hope you remember that intensity, you learned this in your unit 2, that intensity and distance obey an inverse squared law. So if distance increases, the intensity decreases, and keep angle of solar cell to the light the same, because if you keep on changing the angle, the intensity would change as well. And block background light. This is extremely important. Background light also affects intensity. And you might be wondering, what does background light have to do with anything? For example, you start off in the evening and before sunset, of course, and when the sun sets, the intensity ambient light or ambient intensity of your room decreases. So this affects your experiment, of course. Let's move on to part C. State a method that the student could use to increase the temperature of the solar cell. Again, whenever you have to increase the temperature, you don't just hold a flame underneath your solar cell, of course. You need to see the temperature as well as you need to measure the temperature. So what enables you to do both? Of course, a water bath. So one of the simplest ways of changing the temperature of an object is by immersing it in a water bath. For part D, at room temperature, the student measured a potential difference of 2.74 volt and a current of 45 milliampere for the solar cell. Calculate the power. This is the easiest thing ever. Just recall the equation. power equals VI, and please make sure you convert 45 milliampere to ampere, and 0.12 is your answer. For part E, he measured the intensity of light incident on the solar cell to be 200 watt per meter squared. Calculate the efficiency of the solar cell at room temperature. Dimensions of the solar cell are 60 millimeter by 60 millimeter. So the very first thing you'll have to do is convert millimeter to meter, and I have the area. Guys, first things first, you have to understand how does a solar cell function. What is the input and what is the output? When it comes to a solar cell, the input energy is light energy and the output energy is electrical. In other words, you can also say the input power is in the form of light and the output power is in the form of electricity. So power in the form of light is equal to intensity times area. So this is actually a variation of the equation intensity equals power by area. So from that equation you just make power the subject of the equation. And now I have the power in the form of light. But is this power entirely transferred to electrical power? No, that's where you have to bring in the concept of efficiency. So efficiency, as we all know, is power output by power input, and power output, like I said, for a solar cell is in the form of electrical, and we had already found out the electrical power in the previous question. The electrical power was 0.12 divided by the input power we just found out, which was in the form of light, is 0.167. That's my efficiency. And it's not customary always to give the value of efficiency in percentage. You can also leave it in decimal, but it's fine if you just convert this to percentage. That's fine as well. And you can give your answer to 2SF in this context. Let's look at the next question. The student made measurements of potential difference V and current I for the solar cell over a range of temperatures. His results are recorded in the table. Criticize the results. We are really good at criticizing, so these are the points. And the first point is too few readings. So I always ask my students, how few is too few? Anything less than 6, you can say too few readings. And when you look at the temperature range, it starts at 15 and ends at 50. You could have easily increased the range of temperatures, so that is also a form of criticism that you can draw. Too small a range of temperatures. And next is inconsistent intervals in temperature readings. You start off with 15, then 20. The next logical interval should have been 25, but it turns into 30, and then it is 50. So the intervals are not consistent. And finally, inconsistent decimal place in current values. So one value is in 1 decimal place, the second one is in 0 decimal place, and instead of decimal place you could have also said inconsistent significant figures. But just writing inconsistent significant figures is not enough. You need to specify for which specific measurement the values are inconsistent. For example, if you just write inconsistent significant figures, that doesn't apply to the voltage. The voltage values have all consistent significant figures, so you need to specify carefully that which value or which measurement there is inconsistency in. Number 2. Over the range of temperatures shown, the relationship between the power output of the solar cell and its temperature is linear. Describe how the student could use a graphical method to change the input power for each 1 degree Celsius of temperature increase. This part might seem a bit tricky. Trust me, it's not. So the gradient is the ratio of change in y-axis to the change in the x-axis. That's exactly what the question asked for. The hint was graphical method. So this is what you write for your answer. Calculate the power output for each temperature. Plot a graph of power on the y-axis against temperature on the x-axis. The gradient of the graph will give power change per 1 degree Celsius. So power change per unit time is the same as power change per 1 degree Celsius. That's what the question is asking for. Number 4. When an object is in contact with horizontal surface, there is a maximum frictional force F between the object and the surface before sliding occurs. F is given by the equation F equals mu n. Mu, if you have studied mechanics, mu is the coefficient of friction and n is the normal contact force. Where mu is a constant, there isn't mention what exactly this constant is, but it's the coefficient of friction, and n is the normal contact force between the object and the surface. A student investigated this relationship for a rubber block on a concrete surface. She set up the apparatus as shown in the diagram. So you have a concrete slab here, you have a 250-gram rubber block, and on top of that you have a mass. Describe how the student can determine F for the situation shown. What is F? F is the maximum frictional force. So how do I find out F? Increase the mass of the slotted mass until the rubber just starts to slide. Calculate the weight W using equation W equals mg, because it clearly says it's the maximum frictional force between the object and the surface before sliding occurs. So before sliding, just before sliding, the weight will be equal to the maximum frictional force. The student varied mass m placed on top of a rubber block and determined the corresponding values of F. The results are shown in the table. Explain how the values of n are calculated. Use W equals to mg to calculate the weight. Add 250 grams to the mass m. You need to realize that the total weight of the rubber block and the weight of mass m corresponds to the normal contact force. This part is the most important part, everybody. So just the weight alone is not equal to the normal contact force. It's the weight as well as the 250 gram. Then the question says, plot a graph of F on the y-axis against N on the x-axis using the grid below. So this is your graph. The very first thing before even starting to draw a graph is to label the axis. That gets you the mark. So y-axis is force. You're measuring the force in Newton. And x-axis is normal contact force, which is again another force, and force is always measured in newtons. Just writing this, F in N and N in N gets you 1 mark. The next step is to do the scaling. You have to choose your scaling in such a way so that the graph covers around 70% on both axes. And the data given in the question, and according to the data given in the question, this is the scale that I had chosen. This covers around 80% of the entire graph. And last marking point is for the line of best fit. I always say line of best fit is a line where there are equal number of points above and below the line. So if you look at this point, this is technically above the line, and if you look at this point, this is below the line, and rest of the plotting points are on the graph. And you might be wondering, why does the graph go through the origin? Was it done forcibly? No. All graphs are drawn based on the equation. For example, when you have an equation y equals to mx, not c. I mean, there is no plus c. So when you have an equation like y equals to mx, it's pretty obvious that the graph should be a straight line to the origin and the gradient of the graph will be m. But when it says y equals to mx plus c, then only you bring in a y-intercept. So if you look at this equation in the first part of the question, it's f equals mu n. You don't see any y-intercept. So this gives you a hint that the graph should go through the origin. So determine a value for mu. And if you look at the question one more time, once you have plotted f on the y-axis and n on the x-axis, the gradient of this graph gives me mu. So all you have to do is find out the gradient of the graph. F equals to mu n, and mu is equal to the gradient. And while taking the gradient, please make sure that you choose a large triangle. That's imperative, everybody. You have to choose a large triangle, otherwise your value will be out of the range and you lose a mark. So this is the value that we get, 0.56. Round it off to 2SF. And the final part says, a tire manufacturer carried out similar tests on samples of rubber used for tires. Suggest why these tests are necessary. That's because you need to understand to test if the tires are capable of providing enough friction, because the tires cannot be slipping on the road surfaces, and you need to understand the maximum value of friction that these tires are able to provide, so that you make tires that prevent the cars from skidding. Thanks for watching, everybody. Good luck with your exams.